Greetings and welcome to my new calculus channel. My name is John Gabriel. So today I would like to speak with you a little bit about my past experience. I used to teach both AP Calculus, AB and BC, and also A-level mathematics, including the further pure mathematics. And I found that one way to teach my students to obtain high marks in either examination is to do past mock exams. And so I would allow them to take the examination and then give them a full solution, showing them how to do things. But that's not the only thing I want to discuss in this video. I also want to discuss the topic of complex numbers and how it's not really, complex number theory is flawed. It's not really required in mathematics. And I'll show you the typical kind of question that you will get in further pure mathematics, A-level. So let's begin. Now, this question was taken quite a while back. Let's just see here. What was that again? That was 2011. Yeah. It was one of the 2011 papers, I think probably the second one in the year. I don't remember how many they used to have. But in any case, the question was stated as use de Moivre's theorem to show that the sine of phi theta is equal to what you see on the right-hand side here. And then hence find all the roots of this equation. Now, you really don't need to use de Moivre's theorem to find the roots of this equation. Okay, very easy to do without any trigonometry. But that's besides the point. Now, what they really want you to do here is to use de Moivre's theorem to solve it. So we know from his theorem that e to the ixn, where I is supposedly the square root of -1, is equal to what you see on the right-hand side here, which is a binomial in cos and sin x. And so, of course, you could rewrite this as cos 5x plus I sine 5x, and you're on the way to solving the problem. So we can write it down like this and then expand this binomial, as you see on the right-hand side. And then you gather together all the so-called imaginary parts and the real number parts. Of course, they aren't really real numbers. They're incommensurable magnitudes. But I think you'll get the general idea. So the first part is done. So you end up with sine 5 theta is equal to this. And of course, cos is given in a similar way to what you see over there, okay? So now you can expand sine 5 theta as what you see on the right-hand side here, okay? And it all reduces to this expression here, which is what we want. And now if we look at the original equation, which is this, we solve this expression here, 2 sine 5x plus 1. Don't worry, I'll give you a link to this solution and you can study it in your own time. And then we can solve this by reverse substitution, okay? So the second part is similar for either method to find the roots of all this. So what we do is we write it out as the trigonometric identity, which you see on the side here. And if we solve for this, we can solve the equation E by substituting x is equal to sine theta because they look exactly alike. And so when you do that, you come up with all these solutions, okay? So the polynomial of degree 5 has no other solutions, and they're given by this listing here, okay? 1, 2, 3, 4, 5. So, and if you evaluate these, they're roughly going to be what you see down here in this line. So, and this is the graph of the polynomial, okay, as you see it over here. And so the use of complex numbers is not actually required at all in mathematics. There is nothing that can't be done without complex theory, especially when complex theory is based on an ill-formed concept. You have to believe that you can take the square of something that is not a number, okay? The square root of -1 is not a number. So in order to arrive at this definition, one must perform the operation of squaring. Okay? So while it's easy to show that this is equal to this, if you accept that I squared is equal to -1, it leads to absurdities like this ugly formula, which is called the most beautiful formula ever created, but it's, in actual fact, it's truly ugly. And I'll show you how this formula is obtained quickly over here, okay? And you can look at this in your own good time, but when you expand cos x and sin x, as I do over here, then you can rearrange everything, and you'll see how that bogus or garbage formula, as I call it, Euler's identity, was obtained. Okay, totally absolute garbage. Anyway, so one can only guess what the examiner was thinking when he designed this question. So there are too many, in my opinion, there are too many concepts being assessed in one question. This isn't a good idea, by the way, and most math educators have no clue how to produce assessments. The best approach is to test one competency in each question, and preferably not more than two, and make it clear that this is the case by asking the question correctly and without tricks, okay? Because, I mean, if you're putting tricks in, you're not really testing the student's competencies in the subject, but his ability to notice special ways of getting around a particular problem. So this particular question covers a lot of competencies: de Moivre's theorem, trigonometric identities, binomial theorem, solution by substitution, and the ability to see patterns and recognize tricks. Really, not everyone is going to be interested in following mathematics as a career. So when the subject is taught, it should be taught to include everyone, including those who will be using it practically, such as engineers, scientists, technicians, architects, and so on. Okay, so the first goal of an assessment is to test what the student knows, not what the student doesn't know, and what you think the student should be able to figure out on their own if given red herrings and tricks and patterns, etc. Okay, that's not important. And de Moivre's theorem is useless without trigonometric functions. Okay, it's really the trigonometry that works, not I squared equal to -1. It's the trigonometry that you can use to arrive at that, and that's what is used. So one might have thought the author was introducing some new knowledge. For example, the solution of periodic polynomials using Fourier series, but this is clearly not the case, because not all polynomials are soluble in this way. So the question could have been asked by simply stating that 1 plus 2 sine 5 theta is equal to 0 with the reverse substitution of x is equal to sine theta, yielding the roots. So while the level of complexity is too high for the average learner, it is about medium difficulty for an advanced student. Now remember, these stupid math educators, like math professors and lecturers, are always catering to those who are enthusiastic about the subject or advanced, and that should not be the case. They should be presenting the topic in a way that everyone can understand and everyone can master it. And of course, the only way to inspire students who don't have a natural love of mathematics is by helping them understand, not making an assessment so difficult, because really an assessment also has a purpose of encouraging the student that he or she actually knows the content. So it mustn't be an assessment that is impossible to pass, or an assessment that is impossible to get above a certain level, because believe it or not, math educators do that. And that is entirely wrong. It defeats the whole purpose of assessment. Okay? So there is no way to complete the second part without succeeding with the first part. So while the student may know how to find the roots, he or she may not know which reduced trigonometric equation corresponds to the polynomial in x. And so the student has to notice a pattern, which is absolute nonsense. So it's obvious, though, that the author worked backwards to find a polynomial in x that corresponds to an equation in sin x, and probably spent a substantial amount of time formulating the question, which a poor average student has to solve in a limited time period. What does that prove? Absolutely nothing. It proves that most of your math educators are absolute morons who are on an ego trip, who have never really understood mathematics, who want to seem intelligent, and are not really accomplishing anything, okay? And one final thing, not every student is practicing for the Math Olympiads. So the majority are not, and they seek only to learn the competencies and not necessarily to be a good test taker, okay? So now, there are three main purposes for assessment: to prove that the student has mastered the learning objectives, to encourage the student and foster a love for further knowledge, and to help the educators in preparing their lessons, okay? It's not to see how difficult it can be, and it's not about the teacher. An assessment is meant to encourage the student that he or she has learned and mastered the content, and also to teach students to learn independently is not part of the assessment, but it's required as part of instruction delivery. So I encourage you to visit my new calculus site, which is this link here, my new calculus YouTube channel, I'm sorry, and also to visit my site to learn a lot more about how mathematics should be done correctly. So this here may have been a little boring for most of you, but this is typically, in fact, it is a question taken from an A-level paper. So I've solved a lot of A-level papers here, also the AS, and so what I do is, as I said early on, is I help my students by getting them used to the type of questions. I'm not teaching these people as a group anymore, so I'm not really a teacher of record. More like a tutor of mathematics now, but I don't actually work anymore. So for health reasons mostly. Now, this is pretty much it. So complex numbers are really absolute garbage, not required in mathematics. And I'm just trying to show you that since you have to pass these exams, this is the way to do it. As long as you know all these things, as long as you know the marking schemes. That's another thing I do. I also show my students the marking schemes in which they can actually score points even if they don't get the final answer right, simply by stating what needs to be done, as I showed you at the beginning of this paper. And now I'll have you know that my students do exceedingly well. They usually graduate top of their class. I mean, my A-level students get pass with A star, okay? And my A-level students get A's. So they're all very clued up and ready for the loads of garbage that is thrown at them in mainstream universities worldwide. So that's pretty much it for this little presentation. I hope you've enjoyed it. I'll put a link to this article, to the solution, and you can look at it in your own good time. I'm John Gabriel, and this is a new calculus channel. Next time, we'll talk more about the flawed mainstream mathematics and calculus and all the other fallacies. This is a new calculus channel, and I'm John Gabriel. Goodbye.